Hello there. I know it's kind of getting old of doing this, but hang in there. We got a few more weeks left, and then you guys get to enjoy summer break. So we've got, again, just a few other things. We're going to look at rationalizing the denominator. Today you have some notes, so make sure you're answering all the questions here on Edpuzzle, and then also submitting the note sheet in Google Classroom. And then on Friday you will have an assignment that is going to practice using these things. And then that'll be for this week. As always, office hours Wednesday and Friday from 1:30 to 2:15. So I put a link out in Google Classroom for Zoom. So if you have questions on anything, make sure you are logging in there to answer those. All right, first two things we're just going to quickly review. Simplifying a radical. So remember, we're looking for the biggest perfect square that goes into 80. So we could use our calculator. The first perfect square is 4. So we could try that. 80 divided by 4, that works. But 4 might not be the biggest, so we can try some others. So 80 divided by 9, that doesn't work. 80 divided by 16, that works. So 16 is actually going to be the biggest because 16 and 5, there's no other perfect square. So I can rewrite 80 into 16 and 5, and the square root of both of those. So the square root of 16 is 4, and radical 5. So the square root of 80 is going to simplify to that. So 252, a little bit bigger, but we want to find some numbers. So if we just start with 4, the first one, 4 and 63, that could be something, but if 63 has a perfect square, which it actually does, we can keep trying some other numbers. So 252 divided by 9, 9 and 28, so that's an option, but we can maybe see if there's another bigger perfect square. 252 divided by 16, 4 squared is the next one. That doesn't work. The next one after that is 5 squared, 25. 25 is not going to go into 252. And the next one is 36. 6 squared, so 252 divided by 36, which actually it does work. And 7 definitely doesn't have a perfect square, so that's my biggest perfect square is 36. So I have 36 and 7, so the square root of 36 and the square root of 7. Square root of 36 is 6. Square root of 7 stays as it is. Right, so everything that we did last week, our radical was only in the numerator. So now we're going to start having a radical in the denominator. So we got a couple things. One huge rule is we can never have a radical in the denominator. So we can have it to start, but to say something is simplified, I can never have a radical in be in the denominator. So that's super, super important. So this is what, in order to get rid of the radical, we're going to have to do what we call rationalizing the denominator. Okay, so in order to do that, we're going to look at some examples down below. So I have a radical in the denominator. I have square root of 16, but I know what the square root of 16 is. Square root of 16 is just 4. So that equals 4. There's no perfect square that goes into 5, so I end up with just that as my answer. So in that case, because that was square root of 16, that's a perfect square, that just simplifies to 4, and I can say this is simplified because I don't have a radical, I don't have a square root in our denominator in the bottom part of our fraction. I guess same thing over here. I guess I should have picked a different example, but the square root of 16 is also going to give us 4, so our radical is gone, and I have the square root of 15. Again, I should check. 15 doesn't have a perfect square in there, so we would just leave it as is there. Alright, so then let's look at the last 4. So square root of 5 and square root of 2. So square root of 2 is not a perfect square. Okay, so I can't just be like, oh, 1.4 to get rid of that. So in order to be able to rationalize, I'm going to take whatever this denominator is, and I'm going to multiply by radical 2 over radical 2. And I'm multiplying by radical 2 over radical 2 because radical 2 is in our denominator, and really radical 2 over radical 2, that's really just multiplying by 1. And if I multiply anything by 1, it doesn't change it. It's rearranging it. So when we multiply fractions, we know that we need to multiply straight across. So square root 5 times square root 2 is going to give us square root 10. We literally just multiply 5 times 2 and then keep it in the radical. And then if I have square root 2 times square root 2, that's really, if we wanted to do this, we could write it as radical 4. And we know the square root of 4 is just 2. So I have square root 10 over square root 2. I can't simplify if something's inside of the radical and something's not inside of the radical. I can't simplify that and say that that's equal to square root 5. That is definitely not the case. If you're comfortable just going from radical 2 times radical 2 to 2, that's perfectly fine, because really that's radical 2 squared, and the square root and the squared cancel each other, so I'm just left with that 2 in there. And that's why we are choosing radical 2 to make that happen. If I choose any other radical to multiply by besides radical 2 over radical 2, it's not going to work to get that to cancel in our denominator. Okay, so if I look at this one, I look at my denominator, it's radical 10, so I'm going to take and multiply numerator and denominator by radical 10. I multiply straight across. So radical 10 times radical 10 is radical 100, or square root of 100 is just 10. So I'm going to write that as 10. And then I have 15 times 10, which is square root 150. So we got to be careful. I can't just be like, oh, I'm completely done, because I need to figure out if there's any perfect squares that go into 150. So 4 does not go into 150, I believe. So 150 divided by 4, that does not work. 150 divided by 9, that doesn't work. 150 divided by 16, that's not going to work. 150 divided by 25, there we go. So 25 and 6. So I can rewrite this as 25. It's an ugly looking 2, my bad. And then times the square root of 6. So the square root of 25 is just 5. So I have 5. Still have the square root 6, and I still have the 10. So we have to be careful. Another thing, what we can do is I can simplify things that are outside of our radical. So I could take a 5 out of 5 and a 5 out of 10 and get 2. So I could just have 1 radical 6 over 2. Or if I just want to say radical 6 over 2, we could say that. So either way, I guess you can have, but this is going to, these two are your acceptable answers to say that they're completely simplified. So again, I was able to simplify 5 over 10 because they are both outside of a radical. I can't simplify something that's inside and something that's outside together. They have to be both in or both out. Right, so if I look at this one, so we have an extra 4 out in front, but we don't really want to worry about that. I'm just going to take and multiply by our radical 2. So whatever our square root is in our denominator, I'm going to multiply that by numerator and denominator. And really, again, what's in blue is just multiplying by 1. And if I multiply by 1, things don't change. So I multiply straight across in fractions. Square root 3 times square root 2 is just square root 6. I have this 4, but then I have square root 2 times square root 2. So square root 2 times square root 2 is just 2, or you can think of radical 4, which is 2. So I end up having this 4 over here, right? I can't get rid of that. And then these two things are going to just give me 2. So I have 4 times 2. So then I have radical 6 all over 8. Not in a radical, in a radical. I cannot simplify 6 over 8 to be 3 over 4. Because this is inside of a radical, that's not. There's no perfect squares that go into 6. So that's going to be completely simplified. Okay, last one. So look at my denominator, it's radical 5, so that's what I'm going to take and multiply both the numerator and the denominator by. So radical 3 times radical 5 is radical 15. And then I have this 4, so the 4 is going to tag along. And then I have radical 5 times radical 5. Well, radical 5 times radical 5 is radical 25, or just 5. So I just have 4 times 5. So then square root 15, 4 times 5 is 20. Again, I cannot simplify those things anymore because 15 has a radical, 20 does not. So I can't say that that is going to take 5 out and simplify 3/4. It's not going to work. Sorry, I'm yawning again. And then there's no perfect square in 15. So make sure you finish the notes, answer all the questions in Edpuzzle, and then upload these notes to Google Classroom. If you have things that are missing, make sure you're getting those things turned in. Again, resubmit them on Google Classroom, or I suppose if you don't do that, you can always send me an email just to double check and make sure that I update those grades. All right, we will see you all later. Maybe I'll see some of you guys at office hours. Have a great rest.